Hello engineers in making. Now in this discussion, we are looking at a step-down chopper that has the following parameters. A DC chopper has an input of 200 volts and a load of 800 ohms, of course, is connected. Then the voltage drop across the thyristor is 2 volts and the chopping frequency is 800 hertz. The duty cycle is 0.5. We are required to find the average input voltage, the RMS output voltage, the chopper frequency, efficiency, and the input resistance seen by the source. So let's right away begin. So we have the supply as 200 volts. We have the chopper voltage drop as 2 volts. Then we have the duty cycle as 0.5. So average output voltage V0 is therefore equal to the duty cycle times the Vs effective. So the effective Vs, this one prime, is equal to Vs minus V chopper. In other words, the voltage drop in the chopper. So Vs prime is equal to 200 minus 2, that is 198 volts. So meaning that V0 is going to be 0.5 times 198, and this is 99 volts. Next, so that is, this was number 1. So number 2, the RMS of the output voltage. So VRMS of the output voltage is going to be the square root of the duty cycle times the supply effective. And this is going to be 198 times the square root of 0.5. And this is equivalent to 140.01 volts. So the chopper efficiency, obviously it is equal to power out divided by power in times 100. So what is the power output? So the power output is defined by the VRMS of the output voltage squared divided by RL. The VRMS squared, this is the same as 140.01 squared divided by 8. So if we do that, what is this value going to give us? This is giving us 2450 watts. Now what about the power in? So the power input to this chopper is going to be Vs times I0, whereby I0 is the average output current. So this is going to be Vs, we know it as 200. Then the I0 is what we must calculate now. We get I0 from V0 divided by RL. But V0 is known as 99 divided by then 8, and 99 divided by 8 gets 12.375 amps. So therefore, power in is going to be 12.375 times 200, and this is giving us 2475 watts. So efficiency, therefore, of the chopper is going to be what we had as power output 2450 divided by 2475. And we multiply it by 100, giving us 98.98%. So that's the efficiency of the chopper, or what we call the chopping efficiency. Then the input resistance seen by the source. So Ri is always given by RL divided by the duty cycle of the chopper. So this is going to be RL is 8, the duty cycle is 0.5, and this is 16 ohms. So that's all that we can do with this problem. See you in the next discussion.